So this break is intended, apparently. More people are coming in. So this is the real cue. So I take it that you can hear me. Cool. It's nice to see so many people interested in gRPC in .NET here today, because I will admit that gRPC is a niche topic in a way. And people at conferences are interested in what it is and what it can do, but they never get to put it in real production environments. Yeah, so I really hope in the next years this will change. So gRPC deep dive, I'm going to show you a lot of things today, but also I'm going to show you a lot of theoretical stuff. So my name is Irina Scurtu. I'm from Romania. I'm a software architect. I teach .NET from time to time. I often blog. More often now than before. You can find me at irina.codes. Yay, I always congratulate me for that domain. It was money I spent a while ago. I wrote a book. Hopefully this will change. So if you know someone that wants to learn Web API, this might be the book, step-by-step approach. But you're not here to hear about my book. You're here to hear about gRPC. And I'm going to ask you, who here loves monoliths? Because I know that is popular nowadays. Monoliths, right? So we're hearing a lot of modular monoliths or microservices. It's a hype nowadays. But I'm going to admit that for me as a developer, the monolith application was very nice to work with. I remember huge solutions that when we built, we could go outside and get a coffee because that amount of time it took to build the entire solution. Well, I think back in the days, like 15 years ago, that was due to the resources of the PCs that we had for development and not to the monolith itself. The deal with these monoliths is that these are not impossible to scale, but to scale a monolith, it's very costly, because you also scale the things that you don't want to scale. It's all or nothing. You scale it all or not at all. Okay, so also when it comes to deployments, we might have some bad experiences. Again, there it's also all or nothing. Either the deploy works or it doesn't. Okay, we have tools and technologies to prevent that. But we realized that when the applications are written like this, front-end and back-end in the same application, things are not going smoothly every single time. But we started with these kind of applications, with monoliths, or modular or not. Everything were all together, right? So I remember ASP MVC, for example. It was basically a similar app, architecture-wise. We have front-end that was rendered from the server side, and then we started to have a small separation in it. Or web forms. Anyone? Web forms? Yay! Cheers to you, web forms. Then we realized that REST as a concept was a thing. And we started to create APIs and front-end apps. And then we started to distribute them. And we started to have things like this, a front-end app that consumes several APIs or several backends, right? And what happens behind those backends were either we had the single database, or we had several databases, or why not, we could integrate with different other backends. So architecture in here, it was pretty messy. So those kinds of architectures allowed us to have a thing like this, where polyglot environment was possible. Now we could consume maybe a Go app from a Node.js that talks with the .NET Core app and stuff like that. Because we had a common ground between all of them. And that common ground was laugh while you can, rest. So I'm going to ask you, and I'm going to ask you to be honest. Who here ever has written a REST API? Yay, so pretty much every single person in this room has written REST APIs. Cool, another question. So who here ever wrote a truly REST API with those guidelines? I see no hands. One hand, two hands, three hands. Cool. Because basically, let's face it, we kind of do HTTP APIs, right? We expose JSON over HTTP to be consumed from other consumers, right? So we do not follow all the REST principles in its whole. We handpicked every single principle, guiding principle around REST that suited us, right? So at least nowadays we're using the right verbs, at least, hopefully, status codes, right? So we're leveraging the power of HTTP protocol itself, which is a plus. Because I remember a day when the team wrote endpoints where we use post as a main verb, either to create a new REST source, either to update an existing REST source. That wasn't the way to go, right? So what's wrong with REST? Well, nothing is wrong with REST because basically no one will ever replace REST unless we have the special scenario for it. So it's nothing wrong with REST itself. It has its own purpose. And gRPC is not here to replace REST itself. It has, and it will always have its own applicability, right? There are other technologies we need to be aware of, as Blazor, for example, or gRPC, right? So here it comes, remote procedural calls. So a remote procedural call as a concept has been around since the 60s. Yep, we tend to reinvent the wheel, or at least some of the concepts tend to resurface from time to time, right? So RPC as a concept will make a system behave like it's in the same process, maybe, even though it isn't. So we have here some code that does some things. For example, we have a bounded context, creates an order, passes in an order object. Then we have a payment, processing the payment for that order. And then if the payment is successful, maybe we arrange the shipping for that specific order, right? Nothing fancy here. It's method calls, right? Is there anything that tells us that we're calling across the network for every single line of code here? For every single statement, except the if? No, there isn't. Because the purpose of an RPC concept is to make the network communication transparent, okay? So now we're calling a method, but in fact we're doing a request over the network, okay? But we're kind of not aware of it. So this is where REST differs from gRPC, okay? Because with REST, we will have HTTP clients where we would do requests consciously, okay? We have a client and we'll create a request, we're gonna pass in a parameter and we're gonna parse the response back. Look at the status code and things like that. But with RPC, well, we just call methods, send parameters, and that's it. So it's nothing telling us that, well, network call, because it's a distributed system, okay? So RPC it has this call a method look and feel for us as developers. It's prone to errors because of that. We maybe tend to abuse it. But the main goal is to have a distributed system behave like a monolith for our life to be easier, yeah? So how it does it is by making the network communication transparent. We look through it and it's like, it's not there. So enough with the concepts. What is gRPC, right? So gRPC has been around for a while, since that time. Started as a Google Subby internal project. They open sourced it. And in September 2019, we got it in .NET Core. With bad tooling, but we got it. And then it opened up our eyes and we realized, okay, that's another tool to learn, and another tool to learn to have in our tool belt. So what happened back then is with gRPC is that we got it in Visual Studio and we got a new type of project in Visual Studio, gRPC service. And what the IDE did was to basically wrap a compiler with visual cubes, okay? Because if we want to work with gRPC, we can run command lines and get the same thing. But the IDE makes it easier for us. So gRPC, it's contract-based. We will have no-code references. So I'm going to show you what I mean by this. It uses HTTP2. So up your speed, so learn about HTTP2 because this is used under the hood, which will make it faster. It has a different serialization of type protobuf. which gives us smaller payloads. And it's available in many languages. And this is very powerful because once we have this file written, we can compile it to obtain code in Go or Node.js, JavaScript, or in C++, or in C#, only by having this common ground. And that code generation out of the box comes by using the compiler of this protocol buffers file. So where it sits. If we would have a REST API, we would have a client that makes a request to a server. Super simple, okay? Now, in between, we introduce this special file named proto, which is written in a special language that is neither C#, neither Java, named protocol buffers. It's a specification file that allows us to write code that is agnostic of any language that we know. So now that we have this in between, we can write this file that has a special syntax, as I told you. For example, in the first line, we have to specify that we have proto3 as the syntax. Then we have to specify that for C#, we want that this to be generated under my first gRPC namespace. Otherwise, we will generate it as Fibonacci. And then what will we do? We just specify what we want to expose. So in here, we have the keyword service named Fibo, and inside it we have an RPC operation named compute Fibonacci of type requested number that returns a Fibonacci result. Okay? Next, what we have to do is to specify which are the types that this service is using. So we specify that by using the keyword message, we give it the type name, and then inside it we define the parameters. Okay? So bear in mind that number equal 1, that is not an assignment, is the order in the byte string. Okay, so if we would have more, we would have equal 2, equal 3, and stuff like that. So what basically happens is that the protocol compiler takes this file, wraps it, and generates code. And that code is written in whatever we want and need. Okay, so a service becomes a method. A message type becomes a C# class. Yeah, so we take that code and you use it to basically consume and expose this kind of operations. So this is pretty similar to, let's say, WSDL. Remember SOAP, in a way? We had that file where we specify what operations are available, which are the types, and it was very cumbersome. Well, we kind of can compare this with WSDL files, WSDL pages, because we look inside here and say, okay, we have a message named requested number, and this will become a C# class, okay? So in this perspective, those are similar. But gRPC is super powerful because of that, actually. So we have on gRPC 4 types or modes that work on the protocol level. So we have unary, server streaming, client streaming, and bi-directional streaming. Keep in mind that when we have gRPC, we have a connection on HTTP 2, and inside that connection, all these 4 modes can work, okay? So the unary one is where a client opens up a communication channel to a server. The server receives a request and replies. We specify such a request by simply saying, hey, this is an RPC operation or method. It's named like this. It has an input parameter, and it returns that. Yeah, it's very easy. For the server streaming part, still, the client needs to open up the communication channel. So it's not possible directly, like SignalR, for example, where the server opens up a communication channel and sends data. Still, the client needs to, hey, I want to talk with you, and then it will open the communication channel. So server is streaming when it sends back several chunks of data over the same TCP connection. To show that a method is like that, we simply add the keyword stream towards the part that it interests us. So here returns a stream of Fibonacci result. That means the server will send back as a response several chunks of data. So in return, client streaming does the reverse, opens up a communication channel, then it sends several chunks of data, and the server responds with only one. Yeah? Many in, single out. That's the difference. So think about scenarios where we want to upload files. We can chunk them and send them over the same TCP connection without opening new TCP connection every single time for each bit. Or maybe if we want to collect data from time to time from different sensors, that would be a good scenario, right? So no communication channel open every single time. So we depict this as being stream keyword to the part that has many bits. In this part, the client is sending many, and it gets one single thing back. The easiest one, bi-directional, is a combination of the previous two, when we have several ins and several outs, okay? And we simply add the keyword stream to the both part, to the input parameter and to the result. Cool. Whew, enough with the talking. Let's see some code. First of all, okay, I'm gonna escape this. So you will have access to this source code if you want to run it yourself, so don't worry about it. So first, we will see here a gRPC project, the default template, that gives you a few things out of the box. So we have the program CS that is already familiar. We have the app setting.json, of course. And then we have two new folders, in fact. We see here that we have no controllers, as we would have in Web API, for example. But we have a protos and services. So this proto file is the specification that I show you, where in protocol buffers language, we specify what we want to expose. We want to expose a service named greeter with an operation named say hello that gets a hello request in and returns a hello reply, okay? And then we define the types that become C# classes. So after the compilation, these two types become C# classes, and I'm going to show you this. If you look in object debug version, you're going to find the protos, and then you'll see two C# classes. So these two C# classes have funky code with a wording here. Do not edit, because that's the code generation bit. Yeah, so you'll see that funky stuff is happening. But that funky stuff helps us to not reinvent the wheel. We simply pass in the protocol file, and then we'll be able to consume it from a consumer, okay? And also, grid gRPC is a CMOL class. Yeah. So in 2019, this thing didn't happen very well in Visual Studio, and you always had to dig in, delete the file, and recompile to make sure that the classes that you're specifying are visible. Yeah, so if you get things like this, things are going great. The compiler was invoked. So I'm going to hide this. So once we have this specification, yeah, this is what I want to expose, then we can give the actual implementation to those. Okay? So how we can do this? Simply by adding a class. We name it a service. The template names this greeter service. And you'll see here that it extends a base class. Well, this base class is generated in that funky code that I just showed you by the compiler. And we are able, So we are able to just dig in and override what we need in there. Yeah? So we can override the say hello method that comes from the base class. We use inheritance, polymorphism, and things from object-oriented programming that we already know, and give actual business logic in there. Yeah, so that is it. You get base class generated, you override to provide your own logic. Okay? In other way, this greeter service can have everything that you need. You can inject repository, DB context, other services that you need in there to actually have the business logic implementer, loggers, whatever you need. It's a simple class altogether, okay? So with this being done, you'll notice here that under the packages, there's nothing fancy, just things that are common. And this is everything that you need to know about the basic template, yeah? So now let's see it in action. In here, you'll see a server implemented, because you need something to be up and running in order to consume it. Yeah, so in here, you have the grid proto, where we have 4 methods in order to see how these are going. We have a message of type request with the property name content value, and the message of type response which has a message, okay? So I defined this for, and I also gave those some implementation because we have to consume something. So I used the same approach. I extended the base class, and then I went here and override every single method that I exposed. Because if I do this, you'll see that is suggested. Say hello once you start like this. Whoop. Once you start writing public, override. Now I have everything implemented, but you'll get prompted by the IDE what you can override in there. Okay, so let's look at the first one, which is of type unary. You'll see that it's named say hello. It has one request parameter. The deal with this request parameter is that it has to be present. It's not like with the void method that has no parameters. You pass nothing. You have to pass something, even though that something might be empty. And you generate there a message that has nothing in it, but you simply have to pass it in. And then you'll see that you have a second parameter that is named server call context, from where you can extract things like the HTTP context, which sits at the protocol level. This is the same thing that you get in Web API, for example, or in MVC, okay? You extract it from there. Or if you want to extract the user information, if you have authentication enabled, you can go there and just extract claims. You can get the context, certificates, whatever you want to get from the HTTP level, you can get it from there. Okay. Also, you can mimic like request headers, and you can access those. But those request headers, as they are depicted here, are specific to gRPC request. And by the end of the talk, you'll understand what's the difference. Cool. So now that the service it's up implemented, I'm going to save it. And I'm going to have two console up. So I'm going to do .NET run. And I'm going to have a server up and running, yeah, listening for requests. And on the right-hand side, I will have the client that will consume this server operations. Okay, so I'm going to show you how the client looks. And I have here a unary folder that contains a console app. The easiest way to test things, console apps. Okay, so you'll see, as I told you, there are no code references. So now that I have the server up and running, I'm not clicking anywhere here to say add project reference to reference the server, okay? But what I do is to edit the CS project and to add a node. This is the node specific here. So it's a protobuf link that points to that protocol file from the server. Yeah, so also behaves like a client. gRPC services equaling client. Yeah, so this tells the server basically that, hey, this app behaves like a client. And also you'll see here a small thing, link, that creates a rather funky looking folder-ish here. You see a small arrow in there. It creates like a virtual folder for the protocol files. So you can see it at the project level. So if you click in it and you open the protocol file, you'll see that basically is the same one that comes from here, from the server part in here. Yeah, but I do not reference code. So in our case, we won't get any spaghetti code distributed by NuGet packages just because we create clients to distribute in the application, stuff like that. Simply, the things that have these two parts in common is the protocol file. So now you can, I don't know, store it in a different repository and point the projects to that, or find the mechanism in order to distribute the protocol files, because that's your source of truth now, okay? So a thing that Visual Studio did, which I really like, is to allow us to do this. So right-click, not project reference, add, and you have here connected service. That's an option that now works. And you click the plus sign, and you'll select here gRPC. Click next. I'm going to go there and browse and find your specific protocol file that you want to use. For example, I'm going to go to the server part. I'm going to use the protos. I'm going to select the protos. I'm going to click open. And in here, I'm going to select which kind of application I am in, context. So for example, I'm going to behave like a client. I'm going to select that. Also, if you have a gRPC running somewhere in cloud, you can point the URL in there, and it will also help you to generate the code. And if you click next and then finish, what this will do is to add all the packages that you need without you needing to think, I need the gRPC tools or other package. It will install everything for you. So it makes it very straightforward to work with it. Because if you look here, there are a few packages, namely 4, that you need to install every single time. Yeah. And by using this IDE shortcut, just gets it out of your hair. Okay, so this is the unary one. And by looking at the code to see how easy it is to be consumed, you'll see that it's very similar to what you already know from Web API. But this time, we're opening something that is called gRPC channel. So this channel is like a virtual pipe, I can say, that points to a specific address where the server is up and running and allows you to connect to it in order to get data through and from. So I will know that this is the port where my server lives, and then I will be able to create a client. You see, greeter client. The deal with this greeter client is that is auto-generated or generated for us. I didn't write it. It's there for us to use. And we simply pass in the channel, and we have a client ready to use. That's it. So in order to actually make the request, you can say, hey, client, and we're going to be prompted with the options that we have. So we have here the bi-directional, client stream, say hello, server stream, and stuff like that. So all our methods are there just because we share the protocol buffers file with this specific project. Okay, so I'm going to leave in the say hello. We have to pass in the request part. So I created an object here. A new request type, call it instantiated, content value, put something in it, and then pass it in as a parameter. Okay? So now let's say it's running. So we have the server listening, and we have on the right-hand side the client .NET run. So hopefully, you see it's sending hello NDC, and then I get hello back with hello NDC, value from localhost 5000 server. This is the command they're acting out. On the server side here, on the left, we can see some information about what really happened in the request. So you'll see that the request finished. This is the protocol version that it was used. It was a post request. Remember the comparison with WSDL and SOAP? Everything post. Yeah, in gRPC, everything is a post. So we have no way of using other verbs than post because this is how it works. It packs everything and it sends everything as a post, even though you're calling to get something. Yeah. So in here, you'll see that is calling the operation name say hello. It gets 200 as being the OK status code. And it's of MIME type application gRPC, and it took this amount of time. Yeah, so this happens with every single request that we're going to do. Post requests. So this is the unary. The other ones, you'll see here we have client streaming, which is a console project that will stream to the server by looping to this value and simply writing to the request stream, the I value, the index value, and sending a new request type every single time. Yeah. So remember, this happens inside the HTTP protocol. So inside the HTTP protocol, there are small bits that travel while the connection is open. Yeah. So one level below the protocol level. Okay. So let's see it running. Client streaming. Server the same. Listening. Client is streaming. So supposedly now the client will send that loop. Index is sending. What happens? Yeah. So that's why on the left-hand side we see I got a request with content value, and this, I'm going to make it smaller a bit. And you'll see here the request has finished, HTTP2, post, client stream 200 as status code, of type application gRPC, okay? And in here we got this value as being the last value that the server received as single response. A similar thing will happen with the server streaming, but kind of in reverse. Oh, couldn't find what? Server streaming. Apparently I miss. Fingers crossed. So now the servers will send many bits of data to our client. If this is what's intended to show you. So your greeting timed out, okay? Why it timed out? Because I configured it as such. So if we look at the server streaming project, still a console, nothing changed, but we'll have here for address, we have a client. We can call the cancellation token source. That's super powerful. And we can make a streaming call, but also we can set a deadline with that request. So basically we're saying, hey, if you do not hear back a response in this amount of time, kill it. Yeah, so this is why we get the streaming timed out. So if I basically comment this out, it's better to have everything like this because I know it will work. And I run it again. You'll see that we get a lot of hellos from the server, okay? With another additional things that I'm going to show you too. So servers sent these values back in. One thing to emphasize is that this happens over a single TCP connection. Yeah, so no new connections are open. .NET Run for the bidirectional. And we wait. These are not such big values just because, yeah, so we have sending these eyes and that we get the eyes back. Yeah, these are ordered because this is how it behaves. But don't expect the ordering to be like this in every single case because it's not, okay? Cool, let's get back to it. gRPC as a concept, not only that, it has some different ways that, of handling things, but it also has status codes that are different. So we all know the status codes. 401, I'm a teapot, yeah, 404 from HTTP, okay? But when we're talking about gRPC, we're talking about enumeration, in fact, in code of 16 of them that are specific to gRPC, because gRPC request happens underneath the HTTP protocol. So we get doubling of status codes, okay? So these are different. So how can we know that something is happening, bad or not, depending on the status codes that we have? Well, we look at the exceptions. I hope this is big enough. So when something bad happens, we throw exceptions, and those exceptions are of type RPC exception, okay? And we can filter by a specific property of that RPC exception. And we look at this status code, enum, which is that I told you. We have OK, out of range, permission denied, unavailable, unknown, aborted, canceled, data loss, and stuff like that. These are specific to gRPC itself, okay? And if you want to distinguish between all of these, we simply can catch differently and just look at the status code and, I don't know, log things or do your own business logic in there. Yeah, but this is how you can differentiate by status codes and gRPC status codes, because those things are different. Okay. I have some more things here, like request headers. And request headers are a funny thing. So we have request headers at the protocol level, but we also have request header at gRPC level, which are nothing more than key value pairs that are added to the gRPC request itself. Yeah, so this is, just a second, I'm going to have it here. Request headers with get value and stuff like that. Yeah, key values that are added to the gRPC request itself. These are funny types named metadata of type entry, where we pass in a key and a value, and that's what we use. And we simply attach them to the either response where we read them. So depending on where you're sending them, we're using the same type, metadata entry. But if we're sending it with the response, we attach them to something that is called response trailers. And if we send them with the gRPC request, we attach them to the request itself. Yeah, so that's why I told you that it's a funny thing, like this. So we have say hello in here. We have a metadata entry, first key, give it a value, second key, give it a value, and then we pass in as the headers with the request itself. Yeah, I'm going to leave this commented out here just to you to be able to run it yourself. Yeah, so basically they had no way of tackling the things that are neither part of the request itself for gRPC, and they didn't belong either at the HTTP protocol level. So they had to invent things. Yeah, so this is why they invented these key value pairs to attach either with the request of gRPC, either send at the end under the name trailers. The thing with trailers is that, for example, if we have server streaming, the trailers are sent at the end only when all the messages are finished to be sent. So if we have 20 responses to send, the trailers will get at the end. Yeah, so this is the main difference. Cool. So this is one thing, response and request trailers. And some other things that we can tweak is that with gRPC, we can tweak, for example, the maximum received message size. With gRPC, you cannot send like gigabytes of data with a gRPC request. Yeah, so you will have to tweak in different scenarios. Maybe you do not want things that are bigger than 2 megabytes. You can tweak those in there, or to send or receive a similar thing. We can configure things like compression levels, which is very useful in some cases. We can specify the compression algorithms, or you can add your own. Yeah, so this is a case-by-case scenario if you want to tweak this in a way. Also, we have a thing that is named interceptor. An interceptor, it works in a way like a middleware. These middlewares at application level, but interceptor work at gRPC level. So depending on the part where you're putting them, either on the client side or on the server side, those are called server interceptor or client interceptors. Yeah, basically a way of injecting yourself into the request of the gRPC pipeline and the response in a similar way, but not application-wide, just per gRPC request. Security related, well, we have all authentication types that we have with Web API, with one small mention that if you have scenarios where you have Windows authentication, maybe you have, that won't work due to the fact of HTTP2. That won't work with Windows authentication. But when it comes to authentication at gRPC, we have two ways of adding that at the channel level. So you can put things like claims that will be generic, and every client that will be created with that specific channel will have the same authentication things, or at the connection level. Yeah, so if you want it to be wider or smaller, or you want to combine both of them. Yeah. Supported client certificates, JVT, Auth, OpenID, WS Federation. You can check Microsoft documentation if you have a funky scenario around it. But since it's a request, you can add things in that specific request by using, guess what? Headers, right? The key value pairs that we add. And from there, you can extract some things. So there are some other things that gRPC should do awesome, and I want to talk with you about those because they're very important. And I think these are more important than how the internals work. And one of them is named gRPC Transcoding. And this transcoding is not very, not viable. It is viable, but it's not very stable at the current moment. in here you will find a project named Transcoding. I did another app just because for the current time, they're still working at it. And it makes other projects misbehave. So for example, right now, if you have this API and you want to write unit or integration tests, well, your unit or integration test won't work just because you are adding these things manually and it won't know how to reference them. And the things that you're adding manually is this folder structure, Google API notation, proto and HTTP proto. Funky thing, you have to download them manually and to add here. Yeah, right?
Anymore. Since we published google.api.com on Proto's version 2.13.2, I believe, we've embedded the .proto files into the NUGA package.
Yay! Yay! But at the moment when I wrote this, this was like a manual thing. And I said, I look forward to the moment where they will integrate everything, because I think it's super powerful. So basically what it happens here is that you have a specification that allow you to also expose your gRPC operations also as HTTP endpoints in the browser. And I think this will steer a lot of people to actually use this. Because before I say, OK, I have this downstream API that needs to get data from another service, gRPC might be a good fit. But in the end, I might also want to expose this to be consumed in the wild, like from the browser. Yeah, so now we can do that by using gRPC transcoding. So what we have to do is to install a few packages. And one of them is JSON transcoding. Okay, and this will allow us to say, hey, I have this operation named say hello that gets a hello request in and returns a hello reply. But expose this under this endpoint, v1 greeter, and have this parameter bound from the URL also. And this is very, very nice. So if I run this, I should have here transcoding somewhere. I should have the and I also have a README, because I simply don't want to fiddle around. Transcoding. So I have the server running at this specific port. So now if I open the browser, and I pass it like that. So I have this port, v1 greeter, and the name is going to be NDC. I get this back. Yay, which is very cool. But keep in mind, this in browser, it's not full end-to-end gRPC. This is application JSON that gets transcoded, yeah, to gRPC. Yeah, and it's done by this package out of the box, and it's super nice because, right? This package does it for us. Cool. Another thing that I want to show you, because now it's more stable, it's related to the reflection part. So you have to install another package named server reflection. And this server reflection package, if you enable the middleware at gRPC reflection, it will allow us to open Postman, for example. Postman is a tool that I personally use, but I think it's the same in other tools. You click new, you select gRPC, and here you are asked to paste in an URL, but I don't think this is the URL that I have to paste. So I'm going to look through here. 49, fingers crossed. Not that. Where are you? This one. Paste in without ports and stuff, because it's gRPC. And here we'll be prompted to say, OK, how do you want to access what that server has? You can either import the proto file, which is very nice for local development, and you can use server reflection. And of course, it says that you can load server reflection.
It's because you have
Initial 7. Good catch. I'm going to use server reflection. Demo gods, I haven't prayed to them today. Enough? Whew. Yeah, so we have to have this like lock. And it discovers that I have a single hello which is unary by the signs of it. Yeah, and it's very nice, for example, because you can use this a similar thing if it's deployed in the cloud, for example. I just recently tested with Azure, and I deployed a gRPC service, and I tested it from Postman, and it works very nice. Okay, getting back to our stuff here, I realized I didn't show you that we also have here Swagger, yeah, because now we expose an endpoint, right? And we can also document that endpoint, yeah, and we can use it here in the browser. Okay, by heart. Sorry, I simply cannot keep this in mind, where the Swagger lives, index and stuff like that. So I won't bother with it. Swagger, JSON, it's index something. I'm gonna try. If it works in the first try, I'm gonna show you. If not, okay, yay. Yeah, so it's the open API, like documenting what we have in here, which are the parameter schema and stuff like that. 200 as a success. Yeah, so it's in there. Okay, so transcoding, and another thing that it's very important, and I have like a few more minutes to show you. It's related to transient fault handling. And I'm gonna go here. So what libraries are you using for transient fault handling? Except poly, sorry. No other libraries out there. Cool, so where are you? No. Come on. Client streaming. Extras. Here are the extras. Yeah, so basically, we can configure retry policies. We can configure the maximum attempts, the initial backoff, maximum backoff, and of course, what are the retriable status codes, because not all of them would gonna be like considered retriable for our specific business case. So we have unavailable and internal, okay? You pass in the request and we simply use it whenever we're doing the request by passing in the options and the method config in there. Cool. One thing that I want you to notice in here that we can configure either a retry policy or a hedging one. The difference between the two of them is that the retry will try to make a request, say if that's successful, you're gonna do another one. If that's successful, I'm gonna retry and stuff like that, applying your algorithm. The hedging policy will like fire 5 of them, and you're gonna pick the first one that comes back successful and gonna cancel the rest of them. So hedging and retry. Okay, so let's see where I did the call here. Balancer, round robin. Where is the retry? I haven't looked at this. Request. Oh no, so I have the default method config that I have to pass in here. Okay, that happens when I want to use 2 examples in one. I get myself confused. So this is the retry policy, and this is the actual request. And since I'm here, I have to mimic in a way that we're getting an exception. So in the client streaming here, say hello, sorry. I'm gonna see a thing like this. If the gRPC previous RPC attempts is present, this is how it discovers that it's a retried attempt or is the initial one. It looks at the request header, at those keys, and tries to identify if we have something similar. So in here, I'm gonna uncomment this. I'm gonna also stop the server from running because I want to build it again. Okay. And I'm gonna run it. Yeah, so what will happen is the first time we're going to do the request, we're going to see, hey, this is a previous attempt. We have this key. If not, we're going to throw an exception. And the next time, when it's going to be retried, we will act as it is in there. So let's see, the server is running, supposedly, and then we should go to the extra gRPC and run this too. .NET run. And hopefully, client streaming, extras. Okay, come on. Okay, yay. So we get hello back with NDC London value from this specific server. So it looks like it worked, nothing fancy, right? But now if we look on the server bit, supposedly we should get something that is red. I'm going to maximize this, or not, because it's going to disappear. But we have this here. So we have a fail. The server interceptor has a thing that, hey, sorry, I'm going to throw a status code of internal for the gRPC. I'm not here, try again. And you see how when I configure the retry policy, on the calling party, everything worked. So behind the scenes, it has been an exception, it has been retried, but as a consumer, I'm not seeing that. And that's basically fault tolerance example at heart, right? So if we add in here, I'm going to stop and run again. It should run with Visual Studio because if I want that. So debug start new instance. To actually show you how it happens. So running. Fingers crossed. Nah. So it didn't stop for some reason. But yeah, it looks at this specific header. If you want to debug it and you watch there, you can add the watch and you can see how the counter rate increases. And it increases up until it reaches what you specified in here, maximum attempts. And when it's 5, it stops retrying because this is how you configure it. Okay, so stopping here. And the next bit that I want to show you is the client-side load balancing, where you can configure a policy. I'm going to close this in. I'm going to comment it out. Okay, and I have this back. So basically, now we can configure, if we know that we will have 2 server instances or 3 or 4 that are up and ready to serve requests, we can configure this static resolver factory or a DNS resolver factory. We have 2 of them. So we can configure the addresses, and then we can pass the resolver factory, make it a singleton because we do not need different ones. And we pass in here what are the load balancing configuration. We can have round robin, or if you have pick first, these are the 2 available, but if you want to implement your own, you're free to implement your own. So what will happen is I will have the server up and running. One of them is already there. I have another instance that I have to run under a different port. So 5000 and 5002. I'm building this, fingers crossed. Yeah, so this is up and running. The first one is up and running, waiting. And now what happens if I run the extra gRPC several times, I should get the response back, but not before I commented out the exception part, because that was client streaming. It will retry every single time. But even so, let's see. Extra gRPC. Yep. I have to comment this to prevent it from bothering us. So server 1, run again. Server, this we can close. Server 2. This is the port. What do you have in mind? Ho, ho, ho. Fingers crossed now. OK, this is running. The second one should be up and running. This is running. Cool. Yay. We should have I'm going to clear this again. .NET Run. You should get one of the ports. So the first one that responded is the server instance for 5,000. Now if I run it again, you should get the second one. Or not. No build or no dash build. Yay. Yeah, so the first one and the second one. So it's load balancing done right. This is particularly useful, and it's already used by people that are using Kubernetes in their tech stack. Yeah, when they're spinning up new pods, this comes in handy. And I'm talking about people that are not necessarily in the .NET space. In other languages, if they use protocol buffers, they used to use this specific technique. Cool. So these are the main parts related to gRPC. So you can have DNS resolver factory also if you have a DNS there configured, but I didn't configure it locally. Pick first, round robin, and you can implement your own. The benefits of using gRPC are related to performance versus size, payload, and stuff like that. And also polyglot environments. So if you have or want to have a distributed system that will talk with different languages, not only C# and .NET, this is super handy. So you have point-to-point communication, low network usage as a benefit. It's contract-based, smaller payloads, where HTTP2 supports different streaming types out of the box without you using another tool or technology that you have to manage. And starting .NET 6, it can be configured to run with HTTP3, as if 2 weren't enough. Yeah, so quick. Downsides is that you'll still have temporal coupling. It has its own purpose, but you have to think if maybe messaging were broker or brokerless, things might be handy or not for your system. So not human readable, that's remaining from 1 year ago. Postman does everything that you need to do with gRPC. It translates the binary payloads for us to use. You have to have better testing. You'll have to also test the services to integrate, test them, and so on. You'll have also to focus on CI/CD better than you're doing it with Web API, for example, because now you'll have a single source of truth, or you should, the protocol files, and you'll have to make sure that those are in good shape. Yeah. You'll have no caching because HTTP to post. So in summary, it's great for microservices communication if you have downstream APIs that you want to communicate with each other. And also have a look and keep in mind that transcoding is a technology that might gives us the flexibility we need with also exposing it to the browser. And keep in mind that distributed systems are all about trade-off. There is no specific technology that solves it all. Yeah, so you might solve 3 things and get into 4 things bad. So we should know the tools that we have at our disposal in order to make informed decisions. So next step, gRPC Web, because this is a different thing, HTTP 2 and 3, if you want to study more about these. And 1 book, yeah, gRPC for WCF developers, for a fellow speaker, Mark Randall. And if you want to deep dive in it, gRPC in .NET from zero to hero on DOM train by yours truly. So thanks for listening. I'm here for questions, and also you're free to DM me if you have specific questions. I'm gladly respond them. Thank you.